So let us continue. So in my last lecture, we were actually we discussed with one of the compounds of chlorine, that is chlorine. Halogen is chlorine itself. It is clear. Decon's process, electrolytic process. Today we are talking about the second compound, that is hydrogen chloride. So remember this first of all. So HCl in the gaseous state, HCl in the gaseous state, HCl in the gaseous state or liquid state is called hydrogen chloride. Is called hydrogen chloride. Okay. Whereas, is it you are seeing ulta in there? I'll flip it. So what happens is, whereas HCl in its aqueous solution whereas HCl in its aqueous solution is called hydrochloric acid. It's called as hydrochloric acid. It's called as hydrochloric acid. So this is the simple difference between hydrogen chloride and hydrochloric acid. So moment you dissolve in water, what happens? It is hydrochloric acid. Okay. Now how do we prepare? Simple. What you do in your practicals, na? You take sodium chloride, NaCl, and react with concentrated sulfuric acid. If you heat it up to 429 Kelvin, what is going to happen is you get sodium bisulfite, NaHSO4, plus what will you get? You will get HCl. Then this sodium bisulfite, NaHSO4, reacts with further NaCl. On heating, this you heat to a little higher than 823 Kelvin. What happens? You get Na2SO4 plus HCl gas. This is hydrogen chloride. This is hydrogen chloride. Is this clear? Now, from the entrance exam point of view, NEET, both are NEET students. It is clear. So, NEET, I normally write NEET JE. This hydrogen chloride gas has to be dried. It's got some moisture. Now, so how is it dried? Hydrogen chloride, HCl gas, is passed through concentrated sulfuric acid. Is passed through concentrated sulfuric acid. So what is the drying agent? The drying agent is concentrated sulfuric acid. And what happens? And it is collected by upward displacement of, so you can understand, it is heavier than air. Upward displacement, collected by upward displacement of air, not upward displacement of water, because it will dissolve in water, form HCl, hydrochloric acid. So it has to be upward displacement of air. So upward displacement of air always tells you the physical property is heavier than air. That's why I told you in mine. Of course, now it's become hot. Bombay has become hot. Last 1 month we were suffering. What were we suffering from? That it was cold. When it is cold, what happens? Dense gases like hydrogen chloride, sulfur dioxide, nitric oxide, all these are heavier than air. So what happens? They were settling down. So the partial pressure of oxygen decreased, and because of that, elderly people died. I told you, 2 people have died in my building. 2 elderly people died this every season. You will find in Bombay, people die during this season, and they die during this season because of the in total air mein, whatever the oxygen content decreases because poisonous gases content increases. HCl, sulfur dioxide, carbon dioxide, and nitric oxide. All this together decrease the partial pressure of oxygen. Then what happens? Now, ordinary concentrated HCl is what? Is about 37%. Is 37% weight by weight. What is its specific gravity? But they have given it is 12 molar. Huh? 12 molar. So we can always calculate specific gravity. Na? 12 is equal to 10 into percentages 37 into density upon 36.5. I'll just calculate because I'll give you the density. Because I told you, if you remember, they asked. Huh? We know it's 12 molar, but that should not make us overconfident. So we have 12 into 36.5 divided by 370. 1.183. So what happens? Specific gravity is 1.183. So molarity will be equal to 10 into percentage into density upon molar mass. So that will be molar will be equal to what? 10 into percentage is 37 into 1.183 divided by 36.5. That is 12 molar. So this is how they are combining. What will they combine? They will combine inorganic chemistry with mole concept, the first part. Is this clear? Then reaction with ammonia, sodium, okay. A mixture of this, already we have done in nitric acid. A mixture of 3 parts of HCl and 1 part of concentrated nitric acid is called as what? Aqua regia. So what does aqua regia does? It is used for dissolving noble metals. Is this point clear? Then we talk about uses. Okay, what are the uses of hydrogen chloride? Manufacture of chlorine, ammonium, decon process, ammonium chloride, manufacture of dyes, manufacture of glucose, extracting glue, medicine, and galvanizing. Galvanizing, where is it used? Pickling. So if there is a layer of, say, iron rust, you can either treat with sulfuric acid or HCl. They will form water soluble salt and you can remove. Is clear? And it is used for preparation of hydrogen in the laboratory. Zinc plus HCl forms what you call zinc chloride. You can add a very small amount of SnCl2. So uses in the laboratory, uses in lab for preparation of. We don't use this anymore. Huh? I'll tell you what is the logic. Hydrogen. What happens? Zinc plus HCl. Generally, small amount of stannous chloride is added. Then the reaction becomes very vigorous. This is clear. You get zinc chloride and hydrogen gas. But nowadays we don't use that. We use, for preparation a steady stream of hydrogen, we use this aluminium. I'm not writing over here. Aluminium plus NaOH plus water. So that gives you sodium meta-aluminate and hydrogen. That stream is very steady. Okay. So write down this much. Then we are concentrating on interhalogen compounds. Okay. We are finishing this today. 17. So Wednesday, Friday, I'll finish group 18, P block over. Okay, great. Now what happens is, listen carefully. What are interhalogen compounds? What are interhalogen compounds? Just a minute, I'll just see whether the live stream is going okay or not with all this. Keep something, keep a book. That's the best. Yes. So we are now talking about interhalogen compounds. So how do we start with interhalogen compounds? When we are talking about interhalogen compound, so what are interhalogen compounds? Compounds formed between halogen is very interesting. Why? Because see, in group 1, if you look at the other extreme, we have lithium, sodium, potassium, rubidium, cesium, francium. You will realize that nothing happens. They don't combine. They form alloys. Alloy is a physical mixture. They don't chemically combine. But halogens, they are the same group, similar chemical properties, still they combine to form compounds. They enter into a chemical activity. That is why this is unique. That is why this is unique. Is this clear? So compounds formed between halogen are called interhalogen compounds. They are called as interhalogen compounds. Obviously, now write a short note on interhalogen compounds if they ask in the examination. First, you state what are interhalogen compounds, and then what will you say? They are formed because of a large difference in electronegativity, and B, light. I think what has happened is, he has not connected the. Streaming will be there. Priya, can you see the streaming? Now what has happened? The light has, the electricity has gone, but this is on UPS. Only the screen is not visible. Okay. So the large difference in electronegativity and large difference in atomic size. So these are 2 points which we have to talk about. So what is the kind of interhalogen compounds that we come across? The kind of interhalogen compounds that we come across is XXF. X dash, that would be better. So you will have X dash, X dash 3, X dash 5, and X dash 7. So when you talk of fluorine monochloride, fluorine chloride with chlorine, let us say, let's talk like this. With XX dash type, you will have ClF, you will have BrF, you will have BrCl, and you have ICl. Iodine monochloride is a very important use. Huh? Iodine monochloride is used in, it is used in detecting unsaturation in oils. We say now, you always see advertisement. We are, what do you call, we are having lot of polyunsaturated fatty acid. So what will happen? You will be more safe, less heart attack and all that. That polyunsaturated fatty acid, how do they find out? If you are using iron mono, this is clear. Then when we talk of X-3, you will have ClF3, BrF3, IF3. Okay. Then you have X5, you have IF, iodine pentafluoride. You have bromine pentafluoride. And you have chlorine pentafluoride. IF7, here what happens? Only one compound is there, IF7. Okay. So these are the intrahalogen compounds which are possible. So please take down. Then we'll come to preparation, structure and all that. Because the net, the camera and the CPU, they're connected only. Monitor is not connected to the UPS. Fan is also connected. Huh? Okay. Now we come to methods of preparation. Okay. Because some have solids, some are liquids, all that we have to know. Because that will be the kind of factual questions that they can ever ask. Is this clear? So what we have, there will be a coo sound there. Please bear with me. That is because of the uninterrupted power supply. The power supply has gone in this room. We are on the UPS. The UPS gives out that sound, and I can't stop that. Okay. So my apologies for that noise. Moment the electricity, but by that time I think a lecture will get over. So we are now talking about preparation. What about? See, look at this. Chlorine reacts with fluorine, equal volume. Chlorine reacts with fluorine, equal volume. At a temperature of 437 Kelvin, you get chlorine monofluoride. What can you say about chlorine monofluoride? It is a colorless gas. There are some things which are having certain color. First one. But the second one is what? When you take chlorine plus fluorine, where fluorine is in excess. So this becomes a point of view. Na? So you have to always check what are they asking. Whether it's equal volume or in excess. If it excess, then what happens at 573 Kelvin? It forms ClF3, chlorine trifluoride. Okay. Again, it's a colorless gas. Again, it's a colorless gas. And the third one that we have is, okay, formation of iodine monochloride. Okay. What happens in this case is, sorry. So iodine reacts with chlorine. And what happens here? Chlorine is in excess. It forms ICl3. Okay. It's a yellow powder. Iodine monochloride is a yellow powder. So this ICl3, it is a yellow powder. So here, apart from the method of preparation, please concentrate on what is its physical property. The fourth one, if you have bromine reacting with fluorine, okay, here they are diluted with water. Diluted with water, what happens? You get BrF3. And BrF3 is what? It's a yellow-green liquid. It's a yellow-green liquid. Then what do we have? We have iodine monochloride. Very important, I told you. Iodine, this is fifth one. Iodine reacts with chlorine to form iodine monochloride, which is basically a brown-red solid. Brown-red solid. So this is dissolved in acetic acid, and then it is used for what do you call as a for estimate. It has come. Okay, just give me a minute. Let me check if the streaming thing is working. It's gone. Okay. So we have got the electrical connection back, so there is no problem. But we got a few minutes only left now. Now this is brown solid. Then the sixth one, what do you get? BrF5. It's a colorless liquid. Then what do we come to? Interhalogen compounds. Characteristics of interhalogen compounds. They are all are covalent in nature. So I'll write over here. Characteristics of interhalogen compounds. When you talk of, first of all, they are covalent in nature. That's why you see we were dissolving it in acetic acid. Iodine monochloride, we are dissolving in acetic acid. They are volatile, unstable, and diamagnetic in nature. They are volatile, unstable, and diamagnetic. So I would place more importance for diamagnetic nature. So this is something you should know, that all interhalogen compounds are diamagnetic. Is this clear? Then their bond energy is very less than halogen. Since their bond dissociation energy of halogen. So what is going to happen? They are more reactive than halogen. Give scientific reason. One mark question. You should know more reactive than halogen. Fluorinating agent. So ClF3 and BrF3 are strong fluorinating agent. What happened? You said something. Priya, you said something. What? What did she say? Hmm? Okay, last sentence. They are strong oxidizing agent. They are strong oxidizing. So finish this. Then we have only one topic, that is oxyacids of what do you call? We have only to discuss small topic, that is oxyacids of halogen, and that will complete the chapter. Hi, it's Priya only. She wants to say something. Yes, Priya, I wanted to say something. What is it? Huh? I realize yellow. No, it's going to green, become green now. Little blurry. Now, last 5 minutes. Okay, the portion is over. Huh? Bear with me. Because I think now the things are okay, because I'm seeing in the thing it has become green. Yeah, yeah. You can see in the corner red, that is. Hmm? We have a 100 Mbps line, but we don't know sometimes the see, normally we need, I'll tell you, we need 10 Mbps for upload and 10 Mbps for download. So 20, sometimes I think now it's okay. Priya, finished? Ah, okay. Okay. Let's connect. There is the last case. Acids, and I told you, when to a non-metal we have OH group attached, then we call it as oxyacid. When a metal you have OH group attached, we call it as hydroxide. Sodium hydroxide. Yes, Cl, which will not oxyacid acid. So what are the different types of oxyacid we have? Okay, the different types of oxyacids of halogen that we have are, so we have oxyacid of halogen. The first very important one where we can get stuck is fluorine. Fluorine forms only one oxyacid. Fluorine forms only one oxyacid, FOH or OHF, whichever way we write. Because problem is that fluorine will be negative over here, this will be positive. OHF. We'll write it like this. HOF. So HOF. Is this clear? Then what happens? So when we talk of other ones, so we have this table will give us everything. Fluorine, chlorine, bromine, iodine. So it is of the type HOF with chlorine HOCl. These are called as hypohalous acid. Hypohalous acid. So hypochlorous, hypobromous, HOBr. Then you have HOR, hypohalous. Then you have halous. Halous is HClO2. HClO2. Then you have halic acid, halous acid. Here you have HClO3, HBrO3, and HiO3. Then you have perhalic acid. You have HClO4, HBrO4, HiO4. Okay. Structure will be what? OH, Cl. Here the oxidation state of chlorine will be what? Chlorine will be having an oxidation state of +1. Then when we have HClO2, Okay, this is Cl, double bond O, and then you have OH. Here chlorine will have an oxidation state of +3, -2, -1. Then we have Cl. Here you will have +5. Then here you will have Cl, OH. This will be +7. What is the effect of this? Oxidizing power. Let us talk of stability. Stability is HOCl less than HClO2 less than HClO3 less than HClO4. So perchloric acid is the most stable acid. But if it is less stable, that means it's going to give out oxygen very easily. Its oxidizing power will be exactly opposite. So oxidizing property. So this is what we require for our entrance exam. Oxidizing property क्या है? Hypochlorous acid will be greater than HClO2, greater than HClO3, greater than HClO4. So hypochlorous acid will be the strongest acid, strongest oxidizing agent because it is least stable, thermal stable. So it will easily give out oxygen. So this is which we can complete what you call group 17. So Wednesday 6:30 for those who are seeing the streaming, we'll start with group 18. Hopefully we'll complete that day only. Otherwise one more day. Wednesday 6:30.